Thanks.
Cool. Yeah. So so the very high level, the infrastructure is that we have a GitLab.com, which is running on cloud. We have a Postgres DB, which is the main database for the whole system. We don't touch that Postgres database live instance at all. We take so what happened every day at night, like 10:30 UTC hours, we kick off a clone process to create a clone of the production instance in a separate instance somewhere in GCP, which infra team does it for us.
Mm-hmm.
So I'm not sure where exactly it is hosted, which reason and all those things, but I believe it is the same reason because it's quite fast, because they make a clone of the whole instance to us. So during that outtest 10:30 till they say that it takes like half an hour. So we start basically 10:30. We expect it to over by 11:30 UTC because our job kicks in 12 o'clock, exactly 00 hours of the UTC to start the extraction pipeline from that cloned instance, not from the live replica. So every day, right now, we are like 24, not 24 hours, like by the end of the day, we are 24 hours behind. So when we start, we are like till we are just extracting till 11:30 till yesterday. But technically, by the end of the day, when I do the last run, like the evening, so our job runs like every day 6 o'clock, every 6 hours gap. So it's like 00 hours, then 6, then 12, then 18, and then again 00. So we have a 4 hours, 4 interval of pipeline running. So this was done initially. This is the old setup what we have. And this old setup was done because that time we were picking directly from production, not from the clone instance. Since it is a clone, we don't get a live feed anymore. So that was the whole reason. And the clone is good because it gives us a stability, because we don't get an outage and all more frequently. We have got recently last week 1 or 2, but that has come in the 4 5 months 3 or 4 times. Earlier it used to be happening like every alternate week we had an issue that the production is lagging from the catch up. So from this clone, we take the data. So what we do, so we have 2 types of extract happening from this clone. One is incremental extract, like we just take the delta changes based on a timestamp column updated at column. We are for the something around 100 some tables. We take based on the delta on the timestamp. And for few of the tables for which we don't have this timestamp column like updated at, or any column using which we can differentiate that these records have not been pulled yesterday, and we need to just bring in the delta. So for those tables, we do 100% extract. And that list is also quite huge, like they are also like in 100. So smaller table is fine, but we have few tables for which we extract every day 100% clone we do, this refresh we do, which is like something around 100 GB of data we are bringing in every day, which we can optimize it. The target is to do it very soon. We are playing some issues in our board, which we will see that pick up those problematic table and try to bring it over here. So this is we have a 2 extract, incremental and 100% extract, and the 100% one runs only once in a day, and incremental one runs 4 times in a day. So that's the current schedule what we have for this. Now, as part of the extraction, we do a normal copy out from the Postgres, and we write it to a CSV file. That's the proper, and from the CSV, the data goes to as the Google Cloud bucket, GCP. And from there, we load it into Snowflake. So the cycle is same like any other pipeline. We get a raw file, the raw file gets pushed to the GCP, and from GCP, we directly load it into a Snowflake. So that's the side. And then in the Snowflake, we do all the data cleansing and all those till we push it to the Sizen to bring the data model. So that's the overall architecture in terms of like a very simple, all these things are orchestrated using Airflow. So we use Airflow at our side to run this pipeline every 6 hours. And this Airflow runs in the Kubernetes setup, the whole setup where we use the Kubernetes pod operator, where for every table we do an extraction, we spin a pod and we run the whole task on the pipeline over there. So that's on a very high level, the architecture what we have. I believe I saw the Snowplow instance, that diagram what I think Radon has put it. So similar to that over here also, I think the product intelligence team, so your team can help us still in that PGP clone, anything from there which we can optimize it. Like right now, the whole production database is created as what I say for production application specific. The indexing, the partition, all are done for the make the ease life of the application, not the extraction pipeline ease life. Because so, for example, we have a nodes table which is like 850 GB something in production, and that is definitely indexed in the application, but on a different column like ID column or something. But we scan on a column which is not indexed, not partitioned. So every time we do a scan, we run a whole scan of 850 GB. So that is something which we might need to optimize it, look into that how we can do it better. But that all can happen in a clone instant, not into the production. So so that's the on a very high level. Any question till this, Nicholas? I can answer.
Yeah, thanks a lot. This is like a good understanding. So first, my assumption would be like similar to the Snowflake, snowplow diagram that I made. Like we basically are responsible, and like I don't want to say responsibility in terms of like who does the work, but like it's about everyone is
not as a
responsible.
technical thing, but logically we understand.
Yeah. So we are responsible until like pushing everything to GCP, like the CSV. Exactly. This is what you want us to take over. Okay.
Correct. And similar over here. So over here, since we do the extraction, so we run the script to run the extraction pipeline. So responsibility in this world is to keep the clone instance active till that point of time that we have the instance, and to that instance we can reach out to do anything.
And so I will try to repeat what you just told me, and just make sure that I can understand everything. So
yeah, sure.
At 10 p.m. UTC, you start replicating the whole database to replica. From that replica, you start at 0, with a job that incrementally
extracts the data,
and every 6 hours.
Every 6 hours, yeah.
Why so every 6 hours?
Why every 6 hours? Because this was an old schedule. The 6 hour is an old schedule. Because technically earlier, what we used to have, every 6 hour we used to extract last 6 hours of data. That's what we used. But that used to happen in the real production instance where the production was live. But over here, the clone instance is static now. Now we don't get any data after whenever the last clone has been created. So this has to be changed. But we have kept it as it is, that if we might roll back from clone instance to the real-time system, we don't have to go and change our schedule.
So one job would be enough, actually.
Yeah, one should be enough, but we don't want to extract whole 24 hours in one go. The reason is that the volume of data can come and collapse the whole Kubernetes, because if we push in too much data, it all tries to store it in the pod, and from there the container it pushes to the GCP. It directly doesn't write it to the GCP. So the copy out command create a TSV file basically, zip it and push it to GCP. So that whole thing, so what we do a 13 hours cycle. So we do a 13 hours, and then the second run when it happens like 6 o'clock, it does the next 13 hours. So basically we cover the cycle of 24, and the next 2 is just to ensure that if something has failed in last 2 instances, just pick it up from there. So that's the whole.
Okay, and so we have this job. However, we want to design it in the future to be more optimized, and then we have the incremental tables. We can read from them off pretty easily, I guess, as well, because updated at usually has an index, or like created at is usually an index. So we read from them. This is done, and I don't see like there's that you can't really optimize a lot on that, I guess, on that side. And how about these tables that we extract for 100% right now? Is this something where we still see optimizations and that you can know of?
I think we have identified, I have identified like 10 tables out of this list, which has this columns like updated at or created at. There is one column which is having a timestamp. So we haven't done like a full analysis saying that this timestamp is basically it's getting updated. So something we don't want to end up in a situation where we say that we treat this timestamp as for a delta, and we are not basically getting delta from it. So I haven't done that, but we have identified like 10 to 12 tables, which is having a timestamp column, which was not present earlier when the initial Postgres replica was being set.
Okay, cool. And is there like a lot of other tables you can think of like that will never be able to have a delta, and we always need to extract one?
There are lots of table like that. So we have a set of table which is present for which we have everything is 100%. Getting a delta basically increases the timeline to bring in the data from Postgres to this asset, because 100% extract, if it is a small table like 4,000 records or even 1 million, it's fine. But if you have like 100 millions of record and you're trying to export it every day, then it runs for like one job runs for 1.5 hours, something like that.
I see. It's about the updated data. The created data is actually not an issue because you can just look at the ID and use that as a delta. But for updated data, it will be hard. If you can update something that,
Yeah, that's where it is. So for some of the tables we have, but not for all of the tables we have, which is left over now.
Do you have any idea? I mean, there's Postgres also storing logs. Have you thought about that already? Like you can see like these tables got changed.
We want to look into, what we are looking into the future, that we don't want to read the tables. We want to read the Postgres logs directly. So we want to tap on the logs rather than tapping on the table. And we just pick up every change is happening on any of the table directly to our SF world. So for that, there is a really, we are playing an issue for which I am reaching out to infrastructure team. This week I am offline tomorrow, but next week I have the plan to reach out to Gary, asking that I will just share you the issue number. It might give you what discussion we have done till now on this. So I pinged in the chat over here. So this issue, we are trying to explore the data pipeline setup. And we believe that if we are able to tap the logs, our whole pipeline will be quite fast. We might be able to get a real-time feed if we are able to tap the real-time logs directly. There are a couple of infrastructure challenges that they need to expose the logs to us somewhere, and we don't corrupt the logs in order to tap it. So we don't know, us reading it would corrupt it, but even though we get it with a lag of like 30 minutes or 1 hour, they keep pushing the data to some GCP location, and we are able to read it from there, then that would be really wonderful if we are able to do that.
Okay, so is this something you're working on right now, or is this?
Yes.
And you will want to finish it before we take over, or is it something you?
No, I think this is something which is going to happen next OKR or maybe after that. This is something we are exploring it right now, and we will involve you as soon as we reach out to the infrastructure team. I will tag you in that issue. So it will be something that if they give a pushback that no, it can't be done, and we feel that with this way we can optimize the overall performance, then we will reach. We need product intelligence team to help us to back it up. That if we do this, we can bring this data faster to a Snowflake and then to the reporting for the sales.
Okay.
So this is not something which I wanted to tell you about, but since we discussed about this, I thought, okay, let you inform you.
Yeah, absolutely. It's awesome that you already have ideas how we can optimize that in the future. Okay, so I have a few questions there. Chance to optimize. What do you think is the most important thing right now for us if you want to start? If you start at some point.
Yeah, at this point, owning the Postgres replica is something which is not basically all. It sits with the infrastructure team right now. Gary is the owner, or the SRE team is on whoever is on call. They support it because that's an infrastructure setup. For a product intelligence team, any changes happening over there, anything which can impact us, if we get like a heads up that this changes is coming in and this might. So we are already looking at all the application MRs. So any structural changes happening, which is impacting our table definition of extracting the pipeline, we go ahead and we modify, create an issue. But there are certain code changes which they don't drop the table, but they simply stop populating those tables with any data. So we get that alert after like, we have a threshold of like 3 days or 4 days on certain tables. After 4 days, we see that, oh, this table is not getting any data. Okay, let's go and ask the application why there is no data coming in. So that is something which will be coming, but to own it is a different thing, but to ownership sits with someone else. But anything happening on that platform, like the application is changing or something new, there are lots of new table have been introduced recently. So product intelligence team can identify these new tables are valuable, which we can bring it to the Snowflake, and that can be posted. So something which, because recently lots of changes are being made as part of decomposition, they are splitting up their database. That's one thing which we have already taken care. But they will be introducing they're introducing new tables. So those tables, any insight which they needed, application needed, we don't know, because we are not, since those are new tables, we will treat it as a new request, and we don't know if they need it. No one needs, anyone needs it. But
makes sense. So is there, a few more questions around that. Is there any monitoring already set up where you see like, okay, there's something, a problem, and you get notified?
Yeah, so we do. So we have a proper monitoring at our side of two things. If there is a table definition change by default of over there in Postgres, our pipeline breaks simply. So as the very first alert at the 12 o'clock, you will get to know that if the table definition has changed and we have not taken that into our consideration as part of our triage, that we look at the MR and we miss somehow that the table definition has been modified, we get an alert. So that alert comes in, we go back, check the issues board, and that instead of going to the issue board, we can ping to the team that is there any changes happening. Second is the table stops populating data. So they haven't dropped the table in Postgres, but they have done some code changes because of which that table will not get any data anymore in future. We get to know that after like 2 days or 3 days, when we reach that threshold of source freshness, like 24 hours to 48 hours, then we start getting alert every 3 hours saying that this table is not getting data. Can you go and look into it? Can you go and check into it?
And what's the SLA to resolve this?
So if there's like a quite critical table like merge request and something like CI build and all, we have an SLA for 24 or 48 hours. We have a proper defined SLA. It's but I have to pick out that handbook page, which I can point out that these are the SLO defined for all of this. But there is a good SLA. It's like 24 hours to 48 hours. That's the SLA we have.
And how do you deal with that right now? What's happening when there's something failing on the weekend, for example?
So at weekend, we don't monitor over the weekend our pipelines. Basically on Friday evening, US hours, they do that the whole day at triage, and then we pick it up on Monday. So anything fails on weekend, we try to catch it up on the Monday. We don't do a weekend monitoring at this point of time. And we don't do 24 hours monitoring as well. So we do like a business hours monitoring to the system, because the pipeline is quite robust. We do see failures, but not the whole. Only the whole failure happens if like airflow has gone for a toss, then none of the pipelines are running at all. Then that is something like is a P1 blocker kind of thing. Or Postgres has gone down completely. We are not able to extract the data. Then that is a kind of a P1 thing for us.
Okay. You now taking this over, this work, and how would you, let's pretend I would need to hire a new engineer for this, who's taking this over. What skill set do you think is the most important to have?
Okay, so that's where I would need to ask you one question. So as a product intelligence, I understand from Dennis that they, as a team, product intelligence team is responsible to bridge the gap between the application and to the data warehouse. That's my understanding on a very simple term.
I recently described it as we are the middleware of the application.
Application and the DB. So the middleware, we are not someone who can look into the code or understand basically the database and understand that what's happening there, what has gone wrong, and how we can enhance it. So it's more of like how do I say? I'm just thinking that if I need to get a person who need to look into that middleware of thing, who will be the right person? It would be kind of like a DBA person who understand, not like a proper DBA kind of DBA, but someone who understand the database Postgres instances and see that what can be done, how we can optimize it, who can see the logs, who can help us to create a. So right now we have one clone. As part of the decomposition, they are splitting the DB into two, and then the target is to go to 4-5 instance of clone. So someone who can look at all the clones, bring it up if something goes wrong, and who can identify basically that doing this is going to impact the downstream consumer. So something like that. Because right now it is all one reason. Now we go and split the database per clone and per reason we want to make it geolocated, then it would be like n number of instances, someone who can monitor it and support it. So like a junior DBA, we say, who can play with the scripts, who can put a proper monitoring on all the clone instance. If the clone instance goes down, they get the alert, proper alert. And right now we get an alert into the Slack, but it's not like it's being picked up read is intimately. We go and look, we see the failure and we reach to the infrastructure. So someone who can pick up those alerts that, okay, this is like an alert, just inform the SRE team. They go and restart that. Right now it is one, so they all know which one. But eventually when you will have 10, then we have to say which one and all. So that's something which I can think of. I'm literally, I don't have a full answer for
I
that.
know this is hard. So I like, how can you link me a repository where there must be some code where you like pass the data and like push it to GCP?
Yeah. I will send that link as well.
Is this currently written in Python?
The pipeline is written in Python, yes. I will be sharing the master repo first, and then I will give you the path. So this code, whatever is written for, I will say, this is to something which reads the data from Postgres. It's from Postgres to Snowflake. This is not, there is another set of code which infrastructure team manages, which they clone that instance from the live replica to the clone instance. So they have a separate set of code which is present with them. So that runs every day at 10:30 at UTC, timing from there. So over here, I will just give the DAGs, which is responsible. So you are interested in the pipeline which extracts the data, right? The pipeline code.
Exactly.
I'll give you that path rather than giving the DAG path. Transform. I pinged you.
Okay, thanks.
This one, if I can Slack you if you're not copied this one, but
so
this is you forgot. So over here we have two folder for manifest. So manifest decomposed is the one which is the latest one. Just to update you, don't look at the old one. We have to remove the old one because it's just that was the older structure before decomposition. What we have made for this one. So this is something which is the new one where we have splitted the manifest file. So over in this, the SCD one is the table which we do 100% extract, and CI and the non-SCD, any table, any manifest file without SCD is the incremental extract. So the table definition over there and apart from this GitLab.com database, we have another DB. We have a GitLab Ops DB, GitLab Operational DB, and GitLab Customer DB database. Are we aware of that? That also come under your system?
No.
Okay.
So
GitLab Operational is the internal, GitLab internal.
It's ops.gitlab.com, yeah?
Yeah. So that data also we receive as part of this.
Okay.
So that doesn't come as part of the product intelligence framework as a ownership or as to bridge that gap.
I have no idea. So it's I'm
open
asking.
Question.
It's open question. To me, it would be part of it because it's not about the data we collect, but like the infrastructure around this data.
Yep,
like
around it.
And if GitLab, the GitLab Ops DB should be the same structure as GitLab.com, like most up to date. So it wouldn't make a difference to me based on that. It's just where we receive data
correct.
from, right?
Yes, but they are not doing all the changes doesn't go to the GitLab ops. So basically, this decomposition, what is happening, they are not applying it to the GitLab ops DB. They are doing it just for the GitLab.com.
Yeah. I
So
see now
like
what you
that,
mean.
there's like major infrastructure changes are not exact replica. So that's something which as I discussed with the team who was the DBA team who were working on this. I asked them, "Are you doing the same for the GitLab ops?
Yeah,
Because
no,
I need to
that makes
split that manifest file into two in order to say the CI table will be coming from the different source." Then they said no. So like that, that's the reason my question is that are we? So I think this all comes under the your provision, all this infrastructure. So any issue we get it in terms of what I say, the data pipeline that we are not getting data from the source, we should be reaching out to you. Uh, I think that would be something which it comes out as a ownership.
Yeah. You mentioned two systems, like it's GitLab.com, ops GitLab.com.
And there is a customer database. There is a GitLab customer DB. So that is something. And two things which gets pushed from GitLab.com PostgreSDB to us is a version and license information, which is a custom code written by the application team who push those data to the GCP bucket directly. So this is whatever, I'm not sure, we are only talking about the Postgres pipeline, which we run it, but this is another set of pipeline which runs where we don't extract data. The extraction is done from the application predefined code, and that applies for the version, GitLab version information and the license information.
Yeah,
these are
I think for version we already take care of this by we have a pipeline set up that pushes the data as far to my knowledge.
Push data to GCP.
Yeah,
and same for the license, I think so.
Exactly, and I think to my knowledge we at some point want to remove license and only push from version. So we replace version with, like, we don't put, like right now self-managed pushes to license.gitlab.com or like customer.gitlab.com, and at some point it should only go to version, and license application then uses version information. So we only have one database then to care about, but we already take care of this, so this is fine.
Yeah, yes, I was just wanted those are the sources we are receiving data.
Yeah, good,
and if those sources are changing, then we should be as a team, then it should be aware that we can plan the changes, keep it ready.
Absolutely.
That today is going down, we should be aware, and we need to inform the downstream that these data we won't get it in future.
Absolutely. Is there anything I should have asked you I didn't ask?
I don't know, Nicholas. I'm there always. Just you can Slack me if you feel that I need this information. I am available. I work in your hours, so we have a lots of overlapping hours. Anytime you can just ping me. We can jump into a call. We can discuss this through. Great. Not an issue at all.
Thanks a lot.
So I'm available for this. I'm off this tomorrow, and next week is a couple of Indian festival holidays. So we are off, but mostly I'm on. So you can just Slack me. We can get into a call, discuss anything which you like. Perfect. So I will try to put more information around this in the ticket from the handbook and all. So just collate it and put it together, which I will be doing it like next week, Monday or Tuesday. I just wanted to inform you that what we are doing and all verbally, and I understand that what you are expecting from us, what kind of information, so that I don't start writing from A.
Yeah,
you already know lots of things. I just have to tell you
this helped a lot. Thanks a lot. So we want someone who can write Python. I don't think we want to. I'm not sure. I mean, if we take over, I'm not sure if we want to change the language, but let's see. And so.
But why do you feel necessary need to write Python? Will you be doing this whole owning this part of extraction as well from Postgres to Snowflake part, or you will be just
to like from extracting from Postgres? That's my understanding. I understood so far that this is written in Python, right?
Yeah. So Postgres to this, but okay, if you do that, you will be having a bit of challenge. If it can be written in any language, that part, if we are happy to consume it from GCP. Only thing is the way we need to track down that delta thing, that these tables, these are extracted the state, last state, and to this state.
Exactly. This is currently written in Python, I guess.
Yeah, this is currently written in Python.
That's what I mean. Like, it's like when we own this, is like still a requirement that this is in Python. Can it be another language?
Any language should be fine.
Not sure how big the code is, how much it makes sense, but
that's code is very much straightforward on that. It's just doing a loop. So right now we get this source variable. is basically we store it in Airflow in XCOM. So we just push it at the last value over there. So if we have a different scheduler, we just maintain one small metadata table somewhere. We say that this was the last extracted time, and just keep extracting from there. It can be written anywhere.
Yeah, I don't want to switch languages. Yeah, I don't want to switch languages just for fun. It's just like we have 7 or 8 engineers right now that are coding in Ruby. We want to add an additional engineer who is also taking care of this, or like maybe use one of the current engineers takes over. So like if we would, for example, have 8 engineers plus 1 is writing just Python, and I mean the others can understand it and write it, but that's the question. But that's a different topic then.
Exactly. Yeah. But yeah, just to let you know, if you are able to push it to GCP, that's raw file, then language is not a restriction for you, because that's where we have broken the pipe. Basically, the synchronous that infrastructure is broken into 2 parts. Now we read from GCP instead of going to the Postgres. So whichever mechanism you follow, like write it in Ruby and push the data to GCP, it's set so that we are not going to look at that code to maintain it. Yeah. We'll be always now looking to the GCP. So our source of contact will become GCP rather than looking at Snowflake.
That makes sense.
So Postgres. So yeah, it can. Awesome. So you don't need exactly a Python one for that. But yeah, if you need someone to explain the code that what this is doing, we are happy to jump in and explain the code to just give a walkthrough.
Has the current code tests, or is it just when the pipeline fails, it fails?
No, sorry, come again.
Do you have like tests in place right now when we would change something on that code that it would prevent?
We can test it. So we can test it in our. So we need to, as a part of MR, we do the CI pipeline takes care. So we can test it over there. We can run the Airflow DAG locally, and that goes to the Kubernetes. So it's everything works. We can give a demo of like half an hour. How do we set it up? There are lots of videos as well. That how do you run this pipeline from your local to on the Snowflake? So that can be.
Great. I don't want to occupy more of your time.
That's fine.
Thank you a lot.